Okay, so I'm going to begin by showing you again the swing class hierarchy. It's really just a portion of it, but it's the major components, and I'll try to identify the pieces that we're going to be looking at. And then we last time we looked at we had buttons and labels and showed how the content of a J-frame was laid out using this thing called a border layout. Which had the north, south, east, west, and center pieces. And then one thing that needs to be addressed at some point is this graceful exiting, meaning that for an application to be behaving itself, it shouldn't just sort of shut down if you sort of click the red X or even if you click exit. Over time, what happened was there was a lot of regret over prematurely closing something before everything had been saved. Now, in the more sophisticated applications, think of something like a spreadsheet or a Word document. If you're editing a Word document and then say you click on the red circle or red X that closes it, or even if you go File, Exit, or things like Command Q or Control Q to quit, if there are unsaved changes, it will prompt you. It says, okay, you have unsaved changes. Are you sure you want to exit? We're not going to go quite that far, at least today. But today we're going to say, okay, if the user tries to exit, we're just going to show how we can at least give them a chance if they realize that they need to do something else before exiting. So we're going to give them an opportunity to cancel. And how that works is going to utilize this pattern, this way of responding to things called listening. We've already seen that the action listener, that an instance of which can be created and added, or that is listening to the button, and whenever the button gets clicked, then the action performed method of that action listener event component gets executed. So that's how you make the buttons and other things do things. And this action listener, there is, in my view, one of the nicest ways of doing it in a generic way. There are actually other ways, and those other ways are less useful. So we're gonna focus mostly on the action listener. Okay, here's a partial class hierarchy for many of the swing components. And so as we've discussed previously, every class in Java is a subclass of the object class, and this shows that. So there it is at the very top. And then what Java does is it has a series of two classes, one called component and the other called container. And that's because for most of the pieces that we deal with, and those are the ones kind of on the right side of this tree, they act both as a component and a container. So what is a component? The way to think of a component is something you can put inside of a container. And a container is something that things get put inside of. So again, this is a class hierarchy, this isn't what putting things inside, but notice that there's a class called JComponent, which is both a component and a container. So what that means is a JComponent can be put inside of other things, and it can have other things put inside of it. And likewise with window, notice that there are, in window, there's frame, which is actually from AWT, and then JFrame, which is the one that we're using. So we see that if we go all the way up, both using the is a relationship, a JFrame is both a component and a container. Now we will a JFrame we will not typically use as a component, that is, we won't put it inside of other things, but a JFrame is very much a container in the sense that there are things put inside of it. There is, okay, here's this J dialog. Okay, so now what's a dialog? A dialog are those little pop-ups that you see. So a JFrame is like the main window of an application. Although an application can have more than one JFrame. A dialog box is like one of those little pop-ups that you see. So for example, in NetBeans, if you're creating a new file and you right clicks and you say new, then it's a J dialog that pops up because NetBeans is written in Java. So moving over to our J component, we see that, okay, here's one that we've been using, a J label. And even though the way it's written, a J label technically is a container as well, but the way it's written is that you can't put things inside of a J label. So they've kind of overridden that piece and basically disabled it. And likewise, the text components are things a J label, we can put text in, we can put icons in, we can put stuff in, but we put them in not as components, but as sort of more primitive components. So text is the text itself is basically sort of a string. So and not really one of these components, because the string is in a completely different class hierarchy. There's a string extends object out here. So a string is not a component. So a text component, there are two of these, and we will eventually take a look at both of them. The difference is a text field is one of these one-line things where you can type stuff in, and a text area is a bigger box where you kind of see stuff. Now, what we've been dealing with are buttons, and today we're going to extend that to menu items. So
Professor
again,
Buss,
notice, question?
you said a string is not a component. Are any of the primitives components?
No, in this context, a component is something which extends the component class. In other words, when I say that we're putting things inside of other things, those things that we put inside are components. And a component is in this context one of these things. A string is an object, and if I set the label like we've seen a J label, we can set the text of, but that's not the same as these kind of these nested doll things. I say Russian nested dolls. You have a doll inside of a doll inside of a doll, and that's the way that this whole thing is designed to work. So the string inside of a label is kind of more of a parameter or a customization of it. But when we take that label, remember we took the label and we put it inside of the content pane of the JFrame. So that's using the J label as a component and putting it inside of a container. Okay, does that clear it up? I
Yes,
mean,
sir.
I'm not going to emphasize I'm explaining the terminology only as a means to understanding. It's like, I mean, don't get hung up on the terminology. I mean, I think it's important to understand just how these things are designed and how we put things inside of other things. And there are, I mean, in particular, let's see, it's not, this abstract button is, what's important to understand about that is that everything that extends that is going to be one of these widgets that a user is going to manipulate in some way, typically by clicking. So we've seen the J button that we've used. And what's a J button? It's a button like you're normally used to. So you see a button in a user interface, whether it's on a web page or in some application, and you know right away that you point the mouse to it and you click on it. I mean, that's something that we come to expect. When these things were first, when user interfaces were first coming out, a lot of times students in your position had never done that before. Early on, the predominant PC was a DOS machine, which was basically just the command prompt and the entire screen, and there you sort of type stuff. When Apple came along with really the first commercial graphical user interface, it was considered to be kind of a toy and something that not taken seriously. Eventually, that paradigm has become the dominant one. So it was adopted eventually by Microsoft, that came out with various incarnations of Windows, and in Mac they graduated from their version 9 to the version 10, which is what we use today. So the thing is that you've all been using computers for many years, and you come to expect a certain way of interacting with the application. A button is one example of that. The label that we saw, if you just see something that's sort of text and there's nothing to manipulate, then it clearly conveys the impression that there's nothing to click here, whereas a button does. What we're going to look at today is one of these J menu items with the J menu. So we're even though it's these sort of ribbon things have been tried to kind of take over, menus are still around, and they're still important. So we're going to work with that. And as you can see, a menu item, and menu item is one of those things in the drop down that you see. And it is as you can see, it's also one of these abstract buttons. And that means that when we manipulate it, it's going to do the same things that an abstract button does. And in fact, its behavior is going to be pretty much the same as the J button, as we'll see. And that has implications for how we do things, and why these anonymous inner classes that you hear me complain about are actually a very bad thing when we come to do that. And I'll hopefully you'll kind of see what the story is on that. Okay, so today we're going to create a menu, and there are 3 classes involved with that. There's a J menu bar. That is the main, an instance of that is going to hold all of our J menus, and they're going to be in a line across the top of our application. A J menu are going to be one of those columns that you click on and it's going to pop down. And in each of the J menus are going to be a series of one or more J menu items. So a menu bar holds J menus, the menu holds J menu items, and the J menu item acts like a J button. Mainly when we open up a J menu and we select the J menu item, it's just like clicking a J button, and therefore we will activate them using an action listener, just as we did with the J button. And then the last thing I'll talk about today, time permitting, is gracefully exiting. So the desired behavior, what we're after, is to get the user confirmation before we exit. And for that, we're going to need another kind of listener called a window listener. And when a window listener listens to our window, it will hear window events. And window events there are actually a lot of window events, depending on what you do with the window. The main window event that we are going to be interested in is going to be if the user attempts to close a window. Up until now, the default behavior is to close the window but keep the program running. What we've changed that to exit unclose, so that when we close it, we exit. That's something that you do when you're just doing a simple demonstration and you want to make sure that the program shuts down. However, that is very bad behavior in an actual application. Again, supposing you've been coding for an hour on some assignment that the sadistic instructor has given you, and then just for some reason you click the red close button on the window. Now, in NetBeans, it'll say, hey, you have unsaved changes. Do you want to save it? But if NetBeans did what we've been doing, it would just exit and you would lose everything that you hadn't saved. That's very bad behavior. So we're going to use, actually, there's a helper class called the window adapter that it implements all the window listener methods with no ops, meaning that it actually implements the window listener interface, but and then we can just override the one that we want, and that's how we'll use it. And then we will use something called a J option pane to get the user's confirmation. We'll see how that works. Okay, so now in order to do this, I think I need to share the entire screen. Okay, just to review where we were, we had I wrote a class called myFrame and extended JFrame. Again, this is typically when you will extend JFrame to create your main window. We had a J button and a J label for the status. And then we had another state variable, instance variable called number clicks. We were just sort of counting the number of clicks, just do a very simple little task here. And again, here's where we set the default close operation to exit unclose. That's something we're going to override, and setting the size and location, et cetera, and initializing the number of clicks. Now, one common way of initializing this, because it takes a bunch of stuff to initialize all the visual components, that is typically done in a separate method. I'm calling it init. Sometimes it's called init components, initialize, whatever it's called. You're initializing the components. So the idea here was that we had a J panel that was going to hold a button. We instantiated the button and we added it to the panel. And then here we had an inner class. I called it Click Me Action Listener. Again, its name is not important, but the important thing is that it implements Action Listener. And when we add it as an action listener to the button, then whenever the button gets clicked, then this method, action performed, gets invoked. So what it does is, and this is at the J abstract button level, so it means that everything underneath automatically gets it for free. It actually creates one of these things called an action event, and it invokes the action performed method. Now, in this particular case, we're not using the action event. It can be used. It contains information about who clicked it, what was, what other keys were being held down, so you can identify from the event other things about what was going on, if that's important. But in this case, we're just incrementing the number of clicks and then setting the text. Our main method, again, is just very, very short now. We just instantiate one of these, and then now normally for a simple application like this, we could just simply invoke this set visible because instantiating the JFrame doesn't make it visible. Invoking set visible true does. And as you might guess, if we say set visible false, that will keep it around, but just be invisible. So we're not going to do that. Just this little dance right here. Again, here we're using this thing called a lambda. It's either this or an anonymous inner class. This is the one and only time where that's kind of okay. Time permitting, I'll show you why that's not a very good pattern in what's going on here. Okay, so all right, so let's, what we're going to do next is a menu, okay. So the first class is a JMenu bar. Okay, and a JMenu bar is, you will have one of those typically, one per window. And there's a set JMenu bar, yeah. So okay, and so we instead, if you noticed, here, let's run this just to see where we were. Notice when we ran it, there was no menu. Why? We didn't create one, you know, so we still had this click me thing here. And when we closed the window, it disappeared. Those of you who are running on Windows, you will see exactly the same behavior, except the only difference is that it may look a little bit different just due to the look and feel. At some point, we'll talk about what the look and feel thing is about. And on Windows, these little controls are over, or the red X is over here on the upper right. But if you click that, it'll be the same thing. Okay, so because we said exit on close, it's going to disappear. Now, when we put the menu on, let me I have this. So when I run it now, okay, there's actually a menu there, just we can't see it. If you look carefully, you'll see that the line here is a little bit darker, and that's because there's a menu there with no menu items. Okay, so let's, how do we, as I said, this is nesting dolls. So we have a JMenu bar, we put it inside of the window. Okay, so what I'm going to do, where are we here? Fixed imports, yeah. Is, okay, so we have a JMenu bar. I'm going to put a JMenu there, and I add it to, like this. I add what I just created. So see, what I'm going to do is I'm going to create a menu item that's going to allow me to execute the same thing as the click button, the click me button, except via a menu. Okay, just now, even just having added it, we will now see that menu appear. Okay, so see, there it is. Now I click on it, and now you can actually make this live. I can make it so that if you just sort of click on it here, that something actually happens. And in fact, in some of the early graphical applications, especially on Sun workstations, some of the menus, when you clicked on it, it would drop down, and some when you clicked on it, something would happen. That was actually a very bad idea. Okay, so J menu bar, we put it in the window, a menu, we put in the menu bar. And a J menu item, we put, what happened? Okay, so, and then we add this to the click menu, add. Okay. So now when we run it, we see that when we open it up, there's now a click me thing. All right, but it doesn't do anything. So this one does something, but this one doesn't. So what is it that we want? We want the menu to do exactly the same thing as the button. I mean, here's an example. If you're creating a new project in NetBeans, so here's a little button that we can click, and that brings up this. But we can also do File, New Project as well, and that brings up the same thing. So what do we want? We want the same kind of behavior here. What did you, hopefully you noticed that whether I clicked on the button here or the menu item here, I got exactly the same response. So one of those, I want exactly the same thing to happen when I click on the menu. So this button is doing something. I want exactly the same thing to happen here. How can I guarantee that exactly the same thing is going to happen? There's only one way to have a 100% guarantee of that, and that is to have exactly the same code execute every time. When I click on the button, it responds with this action performed method of the click action listener. And so making sure that this exact same code gets executed, ideally by exactly the same object, would be the one way to guarantee that exactly the same thing happens. And it also satisfies the programmer virtue of laziness. In other words, instead of implementing it again, I have this instance of the click me action listener, and I can add that add action listener, the same here. So a couple things. One is an instance of an action listener can listen to more than one component. It can listen to as many or as few as it wants. So now by doing this, by having one object that's a named inner class, not an anonymous inner class, I guarantee now that exactly the same thing will happen. So notice I'm clicking me and the clicks are incrementing. If I say click me now, they increment exactly the same. Why? Because exactly the same code gets executed. And that guarantees that exactly the same thing is going to occur. Okay. See, there is a way of, in fact, this is sometimes recommended, is we can actually create an action listener on the fly here with an anonymous inner class right here. And I'm not going to do it because it's a very bad design. The one place we've seen it is over here. This is the one and only place. if I write a new class here, a new inner class, or even if I write one of these lambdas, I mean, I can write a lambda that looks like this. And notice it sort of takes it. I could do something like that. So what this will do is that when I click on the menu, it's going to increment the number of clicks by 2 instead of 1. Okay, so click me 1. Now look. Oops. Okay, somehow it didn't take. In fact, it didn't do anything. So, all right, this is the better way to go. Because again, this guarantees that this will do exactly the same thing. Okay, so now now what I'm going to do, notice I'm going to commit my changes here. Okay, so and I why? Because what I've done is I set a task, and my task was to create a JMenu bar, show you how to do a JMenu and add JMenu items. And so I'm going to commit that. I'm not going to push it yet, but you can have as many commits as you want. And committing is best done when you kind of reach a certain milestone. So I've reached a mini milestone. I've implemented, I've tested, I've made sure that it worked. So now I want to move on to the next thing, which is gracefully exiting. Again, okay, what was that about? So my desired behavior is I want to get user confirmation before I exit. And to do that, I need to have this window listening thing. Now, again, the behavior right now is not good, because if I click this, it just exits. It not only it blows away the window, it ends the program. I don't want that. Okay, so I need to do a couple of things. First of all, I'm going to change my default close operation to do nothing on close. There are actually several options. In fact, if I look, we can see there's do nothing on close. There it is. That's the one I want. But we saw exit on close and dispose on close was one of the other ones. Yeah, dispose on close. That was the default. Okay, so now I'm going to do nothing on close. Now, out of the box, what that means is that now I can't close it. Notice here I'm clicking and nothing is happening. So I actually have to blow it away from here. All right, so now how can I make sure that something happens? Well, that's where this this window adapter thing. So let me, I have another inner class. So and the interface is window listener. And once I import it, now what's going to happen is that it's going to give me a bazillion abstract methods. See all these different things? These are all the different window events that could occur. Window opened, window closing, window closed, window iconified. That's when you basically hide it. De-iconified it. That's when you bring it back. Window activated. That's when you sort of basically click in it. Window deactivated. And then notice that these are all unsupported. So what so rather than running the risk of having all these bad things happen, Java gives us this thing called a window adapter, which implements every one of these. In fact, notice if I delete them, I'll just, come on. If I just comment them all out, again, no red squiggly. Why? Because they're all implemented. In fact, if we look at the source code for this, we see, okay, it's an abstract class, which means we have to subclass it, but it implements window listener, window state listener, window focus listener, and it just has all these different methods that just are no ops. And what we want is, what we want is this one right here, window closing. And I'm going to delete all the other ones just because it's cluttering up the code. Okay. So it's never used. Okay, well, we're going to use it in a second. Okay, so the window closing event is what is going to be invoked whenever we try to close the window. And so here's how we're going to close it. We're going to give the user an opportunity to say, oh, yes or no. And here's what we're going to use is something called a J Option Pane. And it has a method that says show confirm dialog. And notice that it's heavily overloaded. And what we want is this one. So what it wants here is it wants the component. So now here's one example where we really need the parent of this is going to be our frame. Now the next thing is that it's asking is a message. So the message is do you really want to exit? And then a title, we'll see where that goes. And then finally, and this is a bit of an unfortunate pattern that it was very common, is sort of a magic int. However, what we want is the OK cancel option, meaning that the option, what it's going to do is it's going to throw up a dialog, and there are going to be two buttons on there. One is going to be OK, and the other is cancel. And then what's going to happen is it's going to return a magic result. And what we want to do is we want to test that result. If that result is equal to a particular one, namely the OK option, that is the return value, you see the return value from the method if the OK option is chosen. If that's true, then we want to exit. So now how can we exit? There's a method in system called exit, and we give it a number, and that number we give it is basically and this kind of goes back to Unix days, where if we exit with a value of 0, that means it's exited normally. And if we exit with a non-zero value, that means that there's been some kind of error, and that number points to the error. Again, that's kind of an anachronism going back to the Unix days. But okay, so what's going to happen again is that with this J Option Pane is going to throw up this dialog that says, do you really want to exit? And then depending on whether if the user clicks OK, then we actually exit. If the user doesn't, then we do nothing. And so now in and of itself, this still has not made it live. What we have to do is instantiate one. and then we add window listener. Okay, so the window listener, it's the similar thing to the action listener. So the action listener listens to a button or a button-like thing and invokes the action performed method. The window listener will listen to the window, namely the J-frame, and when this particular thing is done to the window, that is, when we try to close it, it will throw up this dialog. So let's see how that works. Hopefully it'll work because I'm doing it live. All right, so now when I click on the red thing, see now here's the confirm thing. So it says, do I really want to exit? If I say no, if I just cancel, then nothing happens. If I say yes, then we exit.
Sir, can you go up in your code a little bit so we can see the window closer?
All I've done is now I've instantiated it. Again, I've written it as an inner class. If you look here on the lower left, the navigator kind of shows what's happening in your class, and it shows the inner classes. So here's the click me action listener. Here's the window closer action listener, and then it will list the. Notice it lists a constructor even though I haven't written one. So again, what we're doing is we're writing inner classes, and we're adding an instance of those named inner classes, listening to the different things that are happening with our application. Okay, does that clarify things? Again, this is the behavior that we're after. Is instead of simply exiting, we say, do we really want to? And if I say no, oh, there's more to be done, then it says no. And if I say, yep, I'm done, okay, then it's done.
Arnie, when I do that, it tells me I need to create a method for add window listener. Is that, did you create a window or
okay,
a method?
did you extend JFrame?
Yeah. Yes.
Okay, well, I'll have to, I can look at, if you have a few minutes after class, I can look at it.
I'll compare it to yours later.
Okay, so then now there's one more thing that I want to look at here. So say in NetBeans, we also have, notice, and this is fairly typical, there, well, in Mac, it's on this sort of the quit. On Windows, it's typically in the file, and that seems to be a little more common. In other words, what we want is I'm going to create now another menu, a file menu. Okay, and in that file menu, okay, let's add it to the J menu bar. Actually, let me do that up here because I want to do that first. That typically the file menu is the first one up there. And what again, typically there's an exit. Again, Macs are slightly different, but it's very common to have an exit or quit. I'm going to call it exit just because that's a little bit more common. Okay, so now, again, just to see what's running here. Okay, so now we have a file menu and we have an exit, only it doesn't do anything. So what I want is I want it to do exactly the same thing. And how can I guarantee that? I can guarantee that only if I have exactly the same code. Now here I have this window closer, which is a window listener, but it can also be an action listener. And of course, to do so, we need to implement all the abstract methods. Okay, so now regardless of which one of these is called, I want them to do the same thing. So I'm going to write just another method inside this class. Confirm, let's call it confirm exit. And I'm going to put all this code here. Inside there and just call it from here and call it from here. Okay, so now whether I hear the window closed from the red X or I hear it from the file, from the exit menu here. Now, it's not going to work yet. It's still not going to work. Why? Okay, so this still works, but this does not. Okay, why? Because I haven't made it. So here, if I add it as an action listener, not the click me, but the window closer. Okay, so here, this class is a window listener and an action listener. It's a dessert topping and a floor wax. And so regardless of how it's invoked, as either from the window closing or the action event, I have exactly the same behavior because exactly the same code gets executed regardless. And so now, again, I still get the confirm here, or if I click the exit, I get exactly the same thing. And the click me thing still clicks. And I can choose to exit in either way that I want.